This is the first video for Chapter 10, Section 2, Solving Quadratic Equations. Just to be clear, quadratic equations are equations where the variable, or the x value, the highest power it's raised to is squared. It can have linear x's in there, like the linear equations we looked at before, but the highest power is x squared. They're called quadratic equations because it comes from the Latin. The Latin for square is quadratus. And when we raise something to the power 2, we call that squaring. Because working out the area of a square, you do a number times by itself. So 3 squared, the area of a square that's 3 by 3 is 9. The area of a 4 square is 4 times 4, which is 16. And that's where we get that shorthand mathematics. Anyway, there are 4 methods for solving quadratic equations. So there will be at least 4 videos for this section 11.2. After I've done each method in a video, then do the questions in 10.2, should say chapter 10, chapter 10.2 S and A that go with that method. Then come back, watch the next video and do that method. We'll start with graphing, because that's very similar to the linear equations we looked at previously. Then move on to factorising, which is putting them into 2 brackets. That's very useful when you want to find the answer for when the equation is equal to 0. So it's called roots, which you'll see more of in chapter 14. There is a quadratic formula that mathematicians invented in the long and distant past, just to make it easy. And we use quadratic formula when it's tough to do it any other way. There's also a method that mathematicians developed a few hundred years ago called completing the square. It's just a series of steps to manipulate and move the equation around to get it into a form that you can solve it. And the formula ends up looking like this. So I'll show you the steps to do that, probably in the 3rd video of this one, because we're going to start with quadratic graphs. Very similar to the method we use for linear graphs. The big difference is that quadratic graphs are U-shapes. They're symmetrical as well. And those symmetrical U-shaped graphs for quadratics are called parabolas. Here's a question you're sometimes asked to know that name, parabolas. Now the reason they are U-shaped is because they are going back to that idea of squaring something. When you square a negative number, -3 times -3, you get a positive answer. So if you look at this column here, or row I should say, you see the negative numbers, when we square them, become positive. And they are bigger than these here, so they sort of become more important and make your overall answer positive. So 3 times 3 is 9, but also -3 times -3 is 9. And that's why we get that U-shaped symmetry in parabolas for quadratic graphs. And there's the example, a nice U shape there. And remember I said it was symmetrical. You can probably just about make out a symmetrical line if I drew that straight through there. These are what are called the roots, where it goes through, they're equal to 0, where they go through that x-axis, and this point here at the very bottom, which should be on the line of symmetry, is the minimum value. It goes down there to the minimum and then back up. You'll see more details about those things in chapter 14. But let's look at actually using a graph to solve a quadratic equation. The first thing you'll need to do is to draw the graph. So I always like to actually do a big table of results. That's what I spent many years at secondary school doing when I was a math student. Hours of fun with Mr. Watson before the days of calculators. And we'd put all the answers in a table, get the final answer at the bottom. Anyway, I'll take you through an example. The equation is x squared plus 2x take away 3. So this line is always take away 3. That doesn't change. These ones will change because we're getting here x squared. Minus 3 squared is 9, minus 2 squared is 4, over here 1 squared is 1. So when I'm doing the minus 1 value, minus 1 squared is plus 1, because a negative times a negative is a positive. 2 times minus 1 is minus 2. And remember, I always have minus 3 there. Now put them together. So I've got x squared, 1, add on 2x. So I'm going to add on minus 2, and then I'm going to take away 3. Some people prefer to have that as 3 and then just take away that number in there. I'll leave you to work out which is easy for you to see. 1, add on minus 2 is minus 1, and then take away another 3 is going to be minus 4. If we're looking at symmetry, we're seeing we've got 2 zeros here, and we've got 2 minus 3s here. So this is actually my minimum point, and that's where my line of symmetry will be for this equation. Anyway, hopefully you might work out that number there would also be the same as the answer over here for x is minus 4. And for the answer, when it was x is minus 5, you should get that same symmetry of it being 12 over here. You can double check that in your own time. Anyway, working out this equation, this value in here, which is easy because you've got positive numbers, x squared, so 2 squared is 4, 2 lots of 2 lots of x is also 4, and I've got that take away 3. So 4 add 4, take away 3, that'll be 8 take away 3, which is going to come out to be 5. And then just like the linear equations, these are now my coordinates. So when x is 1, y is 0. So I plot the coordinate for that one, 1, 0. When x is 2, y is 5. So for this one, I plot the coordinate 2, 5. Similarly over here, when x is minus 2, y is minus 3. So for this one, I plot the coordinate minus 2, minus 3. I'm now going to move over to showing you me plotting those points on paper via the camera, and also going on to an extension where we put a linear equation on top of it and we can actually solve those. Okay, over to the camera now. Gone for a nice big scale because that helps you to be more accurate when you're reading off. I will need to zoom in so you can see a bit more clearer, but we've gone from the maximum 12 down to that minimum minus 4, and across from minus 3 to plus 3. Been a good student this time and done it in pencil. I will plot the points in pen just to make sure you can actually read them out. So we're going to start from the middle, and we're going to start from when x was 0, and the coordinate for that one was 0 minus 3. So when x is 0, I'm at minus 3. So that's that point down there. X is 0, y is minus 3. If I go across to when x is 1, I had the value that y was 0. So the coordinate 1, 0. That's there. And the coordinate for when x was 2 was y was 5. So I'm now up to there. And we remember the maximum when we had x was 3, y was plus 12. So we're all the way up there. Just to show you the negatives, when x was minus 1, we had the minimum value of minus 4. So minus 1 minus 4 is there. And that will be my line of symmetry. When x was minus 2, I had the value minus 3. So mirroring that point there across the line of symmetry. And we also had the point when it was minus 3 at x, the y value was 0. So again, got that symmetry there. So there you go, we're going to see a nice U-shaped parabola. I'm going to twist it round just to show you a trick for drawing a nice arc. Always useful to have your wrist inside the arc so you can do a smooth curve like that. So if you imagine moving it each time, coming from the bottom, doing a smooth curve, imagine that rotation, and then you can also turn your book around or turn your exam paper around to that side, and again from the minimum doing a nice arc up there. Of course, I'll be a good boy, do it in pencil, so we can see that sort of smooth rotation up to there. A bit difficult when I'm doing it with one hand, but hopefully you can see even with that way it is easier to draw that smooth arc. So there you go, a beautiful parabola drawn. Now going to use it to actually solve the equation, which was to find the value of x when y is 2.5. So what I've drawn there is the line where x equals 2.5, and because it's a quadratic equation we can get two answers for that, just like when we factorise into two brackets or use the formula. So there's 2.5, I now need to read across on that line. I've got a value there, so at this point x, I would estimate that at around 1.55. So x equals 1.55. To be quite accurate because you've got quite a big scale there. And then over here, using the fact that the graph is symmetrical, I've carried on past there to again reach where it's 2.5. Read that down, and that comes out to be, I would estimate the value of x being minus 3. I'm going to go for 3.6 on this one, but 3.55 might also be suitable as well. And they are, in fact, you might notice, symmetrical about our line of symmetry, which is going straight up there. Okay, that's those reading off values from a quadratic. Just now going to put a linear equation on there and talk about that. You may not need this skill at the moment, but just as we've looked at quadratic graphs and linear graphs, I've put a linear graph here on top of the quadratic, and I've done the equation x plus 2. Every time it goes across one, it goes up one, and it goes through the y-axis at x equals 2. So that actually crosses the quadratic graph in two places. So we get two solutions where the equation y equals x plus 2 is equal to the equation y equals x squared plus 2x minus 3, because that's the equation of that line. So we'll use those skills possibly later on in this chapter and certainly in the course, looking for getting a solution where a linear equation is equal to a quadratic. And as you can see, it can be solved by doing a graph of one on top of the other. That should be enough, I hope, to do the graph questions in exercise 10.2. The next video will be factorising, so then you can do the factorising questions. I would suggest you do the graphing ones first and then watch the second video, do the factorising ones after that. Good luck.